welcome back. This is 7.2. We're going to be talking about molarity today. So you definitely need your periodic table because we're going to be finding some molar masses. So we're going to be reviewing that part. It hasn't been super long time since we've done that, but you do need a periodic table and a calculator. So if you don't have one, go ahead and grab it, hit pause, come on back. All right, so let's start off with some background information, and we're going to start off with defining what a solution is. If you look up our definition of a solution, it is a homogeneous mixture. And if you remember to the fall, we said that a homogeneous mixture is one that looks the same throughout. Now, real quickly, a lot of times we think of this as only like a liquid solution, right? We think of like our iced tea, that's a solution. We think of like lemonade or something like that that looks the same throughout. And we think of it as only in terms of liquids, but we can actually have solids solutions. We can have gaseous solutions, right? The air around us currently is a gaseous solution. It's a mix of a whole bunch of different gases, but it looks the same throughout, right? Nothing has changed there. All right, so just be sure that you know that we can have solids, liquids, and gaseous solutions. All right, our other type of vocab that we have is our solute. Our solute is the substance being dissolved. So this is the thing that we added to, a lot of times it's water, all right? But this is the substance being dissolved. And a lot of times, or not all the time, is it like just a solid being dissolved. Sometimes we can have a gas being dissolved, such as the case of our soda, all right? That carbon dioxide that's dissolved in the water that gives us those bubbles, all right? We could also have a liquid dissolved, like when we make vinegar, it's acetic acid dissolved in water. All right, so then we have our solvent, and our solvent is the one doing the dissolving, all right? Substance doing the dissolving. And most of the time, this one is in higher concentration, most of the time, all right? And again, water is a big solvent. We use water as a solvent a lot because it dissolves a lot of different things. All right, a couple other pieces of vocab that we have here. Since we're going to be talking about concentration, we need to talk about a saturated solution. A saturated solution means no more solute. Remember, we can't add any more solute, will be dissolved. All right, so it's like full up. We can't add any more. All right, and this is at a certain temperature. We have, obviously, if we change the temperature, the amount that could dissolve will change. All right, an unsaturated solution then is just the opposite of that. So we could add more solute. All right. So if I added more, like if I have an unsaturated solution of table salt, that means I could add more table salt and it would still dissolve. All right. And our last but not least, we have a supersaturated solution, and this is where we have too much. All right, we have made it unstable. All right, what that means is like we've added too much, maybe by heating it up. Rock candy is made in this manner. All right, we can make rock candy this way. All right, and then they stick the stick in, and that's where all the sugar comes out onto the stick. Okay, but our main focus today is molarity. That's the reason of this. All right, but molarity is a measure of concentration. All right, and if we think of terms of concentration, we're thinking in terms of like how much is dissolved in there, which goes back to our saturated, unsaturated, and supersaturated. All right, our formula for molarity is fairly simple. We have molarity is equal to moles of solute over liters of solution. All right, and just like we did in the fall, we can make a little triangle, our molarity triangle here, and help us solve it, right? So here is moles, or molarity, excuse me, and molarity is abbreviated capital M, all right? So down here, this is molarity, okay? And this is moles, and this is liters. And remember, you just cover up what you're looking for, but something else to help us out here, right? Sometimes, as we have seen throughout this year, sometimes we're at grams and we need to get to moles first before we can plug it in. So if we're at grams and we're going to moles, we're going to divide by the molar mass. And then at the end, it might want you to have grams and take it, or excuse me, have moles and take it to grams. So sometimes you'll have to go from moles to grams. And again, on this case, you'll just multiply by molar mass to get to grams. All right, so we're going to just use that little triangle as a helper for us to solve a couple of problems here. So let's see if we can't look at our problems here. I'm going to try to leave my triangle in the picture. So it says calculate the molarity. So we're looking for molarity. All right, we're looking for capital M of a solution made by dissolving. We have 0.75 grams of Na2SO4 to make exactly 500 milliliters. All right, so we actually have a couple of jobs to do. All right, first off, see how this is liters here. So we have to take milliliters to liters. And to do that, we move the decimal 3 places to the left, giving us 0.5 liters. So over here to the side, molarity is my question mark. Liters is going to be 0.5 liters. And moles, we're going to have to do a little work to get there because right now we just have grams. So let's take a quick look at that. And we have Na2SO4. So as a kind of aside, we need to find the molar mass of Na2SO4. So just a quick review. Na, we have 2 times 22.98977. All right, we have S, that's 1 times 32.066. And then we have O, 4 times 15.9994. All right, 32.066. All right, whoops, and let's see what we got there. So we got 2 times 22.98977. All right, and that's going to give me, boop, 45.97954. Then we're going to add 32 to that, but let's take our 4 times 15.9994 first, and we get 63.9976. We're going to add those babies up. 45.9754, and we're going to round to 2 decimals, so we're going to say 142.04, and that's grams per mole. Okay, so now we're just ready to kind of solve this baby out because our moles is going to take us a little more. And honestly, I really like to just do it on one little chart. And I know you guys are like, oh, the T-chart. Yeah, we're going to use the T-chart. So we're going to start with that 0.75 grams of Na2SO4. And we're going to convert to moles, just kind of like we've been doing all along or for the last few units. We're going to divide by that 142.04 grams. There's our 1 mole. And now if you see, we have moles of Na2SO4 on top. And if we just divide by that liters right there, we'll have moles over liters, which is our official label. Well, it's not our label. It's how we solve for molarity. So now we're ready to just do the math. So to calculate this, we're going to take 0.750 divided by 142.04 and divided by 0.5, and that'll give us our answer. So 0.75 divided by 142.04 divided by 0.5, and we should get our answer. And our molarity, let's keep like 3 digits in our answer, so we're going to say 0.0106, and that is our molarity, and it's labeled with capital M. You can leave that Na2SO4 on there, or you can leave it off. It is your choice. All right. Awesome. Awesome. Let's roll down and see if we can kind of answer the opposite of the question here. This time we're looking for grams, and we have milliliters and molarity. All right. So as an aside, we need to find the molar mass real quickly. So let's do that real quickly on the side, but we might not go through all the work there. We got K2, CR2, O7. So we have 2 Ks, 2 CRs, and O7. So let's go ahead and take 2 times 39.0983. And then we're going to add that to 2 times 51.9961 plus this time 7 times 15.9994. And our molar mass here of K2, CR2, O7 is 294.18. grams per mole. Okay, so again, starting with what we know, and this has got to be in liters, so let's do that conversion real quick. Move the decimal 3 places to the left. So we're going to get 0.0500 liters, and so we've got 0.488 molar, right? And remember, molarity is just moles per liter. So if you look at that, if I have liters right there, I'm going to put liters on top to get liters to cancel. And if I go back up to my triangle, right, I'm looking for moles, so I would cover up moles here. If I cover up moles, I take molarity times liters, which is what I just did right there, okay? And then we're going to multiply by our molar mass because we want to say 1 mole is equal to 294.18 grams. And now we're ready to calculate. 0.488 times 0.05 times 294.18. And our answer, keeping 2 decimals, 7.18 grams of K2Cr2O7, or potassium dichromate. All right, awesome. Cool. See you next time.